All right, welcome to today's video. In Lab 7, we worked on a very simple console app that performed some type of calculation, and we would output the results on the screen. So if we had some variable that was an integer data type, and we initialized it to, let's say, 5, and we had another integer bucket variable, if you will, and let's say this number was 2, and we wanted to divide number 1 by number 2 and store the results in some other output variable named results, we would take these steps, right? Create input variables, output variable, and perform the calculation. Once we're done with that, we want to display the results on the screen, and then I'm calling console.read to pause the screen so we can see the output. So if we were to run this, we get the result 2, right? This is not necessarily accurate because I'm using integers and things are getting rounded, right? So I could perhaps change this to a double data type, change that to double, round that again, and now I get the results 2.5. So that would be one of the reasons why you would want to use double over integer when you're doing calculations, even though 5.0 is really a integer number, right? So keep that in mind when you're performing calculations. It might make sense to store your variables as double data types because you anticipate that when I'm dividing number 1 by number 2, potentially the results would be double, right? Now, sometimes if I anticipate that I might have an error message, right? So when I divided and I had the integers, the answer was just wrong. There was no error. But let's say I try to divide by 0, right? We know a typical calculator app, right? When you divide by 0, you would get some type of error. But the error might not be user-friendly, right? So we have different ways of catching an error, we would call it, and perhaps handling it by showing a more user-friendly error. So I'll show you this example. Now I have number 1 set to 5, number 2 is set to 0. 5 divided by 0 would be stored in results, and then I'm going to write line into this piece. So I'm going to click start, and I get infinity, right? Let me just go ahead and change this to int, change that to int, and divide by 0. And what you would see here is I get some type of exception, right? So attempted to divide by 0, system.divide by 0. The application actually stops. You can't see the console app at this point. I have an error and everything just stops, right? So what I would like to do is when there is this exception or error, right? Exception simply means some type of error. I might need to handle it. So this is an unhandled exception. I did not handle it. So it just stops my application from running at this point, right? So to do that, there's this concept called try-catch. So somewhere in your lecture slides you would find exception handling. And try-catch allows us to try to perform some action, right? So we have the keyword try, all lowercase try, open curly, close curly, catch. This exception EX is optional, and I'll show you how that works. And so if we perform some action here and it breaks, I might want to show a specific error on this step, right? So let's look at how that would work. When I first executed this, I know line 19 is where my code breaks because this is the execution stops here and this is highlighted. So potentially I can put a try-catch block around this code because I know if a user enters in a number 2 that is 0 and I try to divide by 0, I would have some type of error. So I'm creating my try block and I'm going to move my code into the try block. You always want to see this indented. That means you're doing something right. But we can't use try by itself, right? Because you get this red squiggly line you've hovered over it said expected catch or finally. For now, we won't talk about finally, but we need a catch. So if we try something, then we need to be able to catch it. All right, so I'm going to catch. And when I catch it, I'm going to perhaps show something on the screen. So let me move this actually in here. Let's move this line of code in here. So if I divide and this works correctly, I'm going to show the results. Otherwise, I am going to show the user something else. I want the program to continue to run, but show a user-friendly error on the screen. So I'm going to use console.writeLine, because this is a console app, right? And this time I want to show cannot divide by 0. Cannot divide by 0 is just one of many types of exceptions that can happen. So if you anticipate that an error would happen, potentially because you debugged, you thought about some use case, alternate path to your code that might result in an error, then you can use a try-catch block to handle those types of things. So let's run this now. So I run this, I see cannot divide by 0, right? So instead of the program just stopping, so the user can't see the screen, now I'm actually handling it so the program continues to run, but then I can see a very nice user-friendly error message, right? And that's how you see error messages on web pages, so on and so forth. So this is something you're going to want to add to your toolbox. When you program, you want to use try-catch to catch exceptions when you anticipate that there will be errors. And that's a skill you're going to build over time. Now we'll look at the example where you have to try-catch with the exception. This is optional. If I use try-catch exception, I could use a property of the EX. This is just a variable called EX, which is a type exception. Exception is a type. It's a data type. So I could write EX dot, let's say, message. It has lots of properties. So this would be error is something like that. So I'm going to concatenate the actual error, display it on the screen. If I run this, I get cannot divide by 0. Error is attempted to divide by 0. This is the error that Visual Studio or the .NET framework is actually throwing, right? This is something that I'm handling. I'm handling and showing that. So sometimes when you're debugging, it might be useful to use this EX variable. This could be JX, right? It's a variable name. It could be anything, right? And you can use something like that to help you debug your code and figure out where things went wrong, right? So that's error handling. One of the things I want you to try on your own is try a nested try-catch. I'll look that up. There's a likelihood you would see that in a future exam, and I want you to be well aware of. So nested would be perhaps I'm anticipating that there might be some exception when I try to call this, so I could wrap this in another try-catch, right? And sometimes I might catch it and handle gracefully. Handle gracefully means when this is handle gracefully is just a comment. So if I catch it and I don't do anything, that means that anytime an error occurs on this line, it will just skip this line, right, and move on to do something else. And think of the logic. This is going to run first, then that would run, then this would run, that would run, this line of code would run, and then we'll pause the screen. Right? So you can have nested try-catches. It's a very interesting concept to be aware of. So let's go ahead and run this, and we get that. I'm going to change this to, let's say, 2, and I want to see, I want to round any numbers up. So I'm going to change these to double and run this again. I get 2.5 because I'm not dividing by 0. So when this code runs, right, 5 is going to be divided by 2, and we're going to end up with 2.5. Now, this is where I show the results. In your lecture slides, you get access to a whole bunch of formatting options, right? So you want to run through these, how to format a string using toString. If we want to show a $, we'll use toString C, so I can do something like this. Assuming 5 divided by 2, I want to show the $ in front of it. I can use results.toString, double quote C in there, right? So run that. You see $2.50, right? I get 2 decimal places and the $ in front of it. This is going to be awful useful when you're making calculations. We need to show some currency values. If we need to show some percentage symbol somewhere, I could change this to lowercase p, uppercase P. This is, you want to look at your lecture slides for guidance. So let's just give that a shot. So you see the percentage symbol, 250, something like that, right? So you get the idea. Now, if I need to show 3 decimal places, I could do toString N3, and it'll look something like that. 2 decimal places with no $, N2, you get the concept, right? This would be good if we're doing some type of financial calculation. If we want to use leading zeros, so let's say we're doing something with social security numbers and they can have leading zeros. They look like numbers, but they're really strings. Then I could do something like D4, which would have, if the number is actually 23, add enough zeros to make it 4 characters long, right? So this would be 2 leading zeros in front of 23. Some concept like that. If we're working with date time, we can use lowercase d to show a date format that looks like this. Uppercase D to show a date format that looks like this, long date. Lowercase t for short time, uppercase T for long time. And if we want to show long date and time, you can use uppercase F. So let me show you how to create a date time data type value. So let's say no matter what we do, we want to show the current date and time. I think we went through this already, so this shouldn't be new. So let's say we're creating a variable which is a date time data type called myDate, and we're going to initialize it with a date time now. Date time now gets the current date and time, right? So then I'm creating maybe some other variable string called date, and that would be equal to myDate dot toString, and I could pass in toString D, for example, right? So that should be short lowercase that. I'm going to copy this just because I'm a little bit lazy when it comes to these things. And typing fast is not necessarily what you want to do here. You want to make sure you're very precise. Don't type quickly without paying attention to what you're typing, right? So in this case, I want to print out this variable that I'm creating, date. Or I could simply print this out one line. So I'm going to go ahead and do that. Right, so I'm just going to print out whatever the value is. I could do this and just print out what's in date, but this is just an example. Anyway, so I'm going to do console write line, show the current date and time, but show it in this format. So if we run this code, we get today's date, and it's in that format. Right? If we just want to show the current time, I could, or maybe let's do long date. So uppercase D, run that, shows September 2008. Let's do uppercase F. You get that. And if we were to do, let's try uppercase T, we get the current time in that format. So that's the idea of what these slides are trying to cover. So make sure you go through those, play with those, get comfortable with it. Next concept is to attempt to build this lab. The lab is published on D2L. I'm going to get you started by helping us create the recipe for making the calculation to build total rooms. you would need to build out the total additional charges on your own. Total additional charges would be room service plus telephone charges plus other charges. You simply want to add these three numbers together, and hopefully that comes up to 18.75. You can use this as test data to verify your work, right? Then you're going to have taxes, which is 8% tax rate. So you can do some type of calculation of the subtotal. So subtotal will be total room charges plus additional charges will make up the subtotal. Then get taxes on that. Add the taxes to it, and you should get the total charges. Right? So you can do build this app. But I'm going to help you build number of nights times nightly charges to make up total room charges. And then you would have enough to get moving on this, right? So we need to identify, first of all, the events, right? So when the page loads, I'm assuming that I might need to print out the current date and time when the page loads. Now we're not going to worry about updating the time on the fly. When we built this, you're gonna have to refresh the page to see the current time. Eventually, when we learn a little bit more about JavaScript, you'll be able to do partial page refresh and actually refresh the page maybe every minute to show the current date and time, the current time, with that actually ticking, right? So we're going to build a little bit of a framework. Mine isn't going to look quite as pretty as this, but when you do it, you're going to have to make it look close to this. So use tables. I'm going to have to whip this up pretty quickly to make up this video, so I won't make it look as pretty, but you might need to spend some time making this look more professional. Right? So to do this, let's get going. I'm going to close out of this console app. This time we want to build a web app. So typical recipe, file, new, project. You're looking for web. So this is Lab 8. I'm going to go ahead and mention Lab 8. If you follow this tutorial, you'll be halfway through Lab 8 by the time I'm done with the video. Right, so I'd encourage you to fire up Visual Studio and let's get rolling. I'm going to select Empty, Web Forms. Okay, we're probably very comfortable with this at this point. I'm going to close out this window. We don't need that guy. I need to see my Solution Explorer, so let me pin that here. I've got a blank project. I need to add a web form. I'm going to right-click on the project, Add, Web Form. And I want to call this default.aspx, but you probably know what default.aspx is. I get a nice blank screen. I'm going to switch to design view. Wow, we're very comfortable with doing this. At this point, I can hide the Solution Explorer because I no longer need this. I will bring up the properties because we're working with a website and we need to design the page. There's a good chance we might need to add some controls. So I'm going to bring up the toolbox. I'm going to need to drag and drop some controls onto the screen, and I'm going to need to set some properties of those controls. Okay, so let's start by looking at this. I need to show the date and the time. This is going to be dynamic, so it's going to be in my C# code. To do that, I would probably want to use a label control, which is a read-only control. So let's, I'm going to go ahead and call this Motel 6. Right, it's the name of my app. We'll do today's date, and I'm going to use a label control. When you're working on this, you're going to want to use HTML tables, just like we did in the previous video. But I'm going to cheat and do this quickly using this approach. I'm going to highlight Control B or Command B on my keyboard to create this. I'm going to create all the controls I need, then I would go back and actually assign unique IDs to every single control on the page, right? Then I've got number of nights and nightly charges. So I need a text box, and right above that is number of nights. Let's fix casing on here. Then let's go ahead and do nightly charges. Nightly charges. Got another text box in here. We need room service. Room service. Phone. phone, other charges, and then we're going to have a button somewhere. Plug in some text boxes in here. And we'll leave room for a button control. Right? Button is going to plug in here somewhere. Make it look nice and pretty on your end. I don't have enough time to do that in this video. Then we're going to have total room charges. So I'm going to have total room charges. And that would be using a label control because that's a read-only field. Right? So if I have read-only, I'm going to use label controls. Then total additional charges. Then I would have subtotal. Then I would have taxes, total charges. Let's say tax to match total charges, something like that, right? Add a label, add another label, and you get the idea. We're going to use labels in those areas where we anticipate that we need to show read-only content, right? Something a user is not going to be able to change. All right, here we go. I think I've got something nice. I'm going to highlight all of this, actually, all of this stuff, and just do Command B because I just want this to look slightly pretty. I want all those charges to be in bold, right? Just for now. Next thing I need to do is assign an ID to each one of these, right? So again, go down and set the ID. This is going to be LBL date. Keep it simple. I'm going to remove the text property, and you can see I can now see the control name. So when this starts, the default value is going to be blank, right? So hit the delete on the keyboard. This would then be LBL time. You can name it whatever makes sense to you, but you need to, if you rename it, when I write my code, you would need to pay attention and use the values, the control names that you set, right? So text box, this is going to be txt num nights, number of nights. I don't want to type the whole thing out. This would be, you want to use something descriptive. txt nightly charges, or daily charges, or something like that. This would be txt room service. This is txt phone. This is txt other. All right. This button control, we need to set two properties. Number one, it needs to say calculate total charges. So I'm going to set the text property of the button. That's what controls what displays on the screen, right? The whole bunch of options here. Maybe let's go in and set bold, right? I want this to be bold, but you can play with all the settings that make the most sense to you. Change the color. I leave you to explore that and figure out what the best values. But I'm going to name this btn calculate. btn calculate. Okay. This label is going to show total room charges. Okay, so I'm going to set that, and for label controls, I want this to be blank by default. Okay. Then I'm going to change that to be blank by default. And it will be LBL additional charges. This guy would be text property would be blank by default, and it will be LBL subtotal. Right? Then I've got the tax. Get rid of that. and we're going to use LBL tax, but you get the idea by now. LBL total charges. We'll make that blank. All right, so now let's run this. Make sure it runs successfully. I'll give Visual Studio some time. It's loading, 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 still loading, and boom, I've got a nice page, blank total date, blank time, got some text boxes. Click on this, nothing happens, nothing shows. This is what I wanted, right? So that's a good start. First thing I want to do now is write some code to show the date and time. Now, you would have to be able to identify the key event handlers here because we need to write C# code in a given method or event handler, right? So I think I need to show the time when the page first loads. So I'm going to use a page load. I'm going to double click the white area here, right, to create a page load event handler. And if you recall what I showed you previously in a previous video, you can split your screens. We'll make this a little bit easier for ourselves and select new vertical tab, right? Maybe move this to the side. Maybe make this larger so I can get a chance to show you what I'm doing here. Okay, so the first thing I want to do is create a variable to hold today's date. So today's date. Notice I'm not going to put special characters in a variable name, right? If I do this, that's not going to work, right? Today's date, something like that. And notice I'm using camel case, lowercase, to start the first character in a variable name. That's just good convention, right? So get in a habit of doing that. Doesn't mean it's going to break, your code is going to break if you don't follow the convention, but it'll be best practice. So I've created a variable holding today's date. Today's date and time is in datetime.now, right? And now I need to show this on the screen. But I need to show it specifically in LBL datetime, right? This guy. So I need to use the control.property convention. So I'm going to set the value of LBL date dot text. The text property is what actually holds the value that would show up on the screen. This is just the name of the control. Do not confuse control names with variable names. Variables are just containers. Controls are widgets on the screen, right? Sometimes students get confused. So now we're going to say LBL text is equal to today's date. But if I were to end here, notice I have a red squiggly line. The error says cannot implicitly convert datetime to string. That is because if I hover over text, that text is always a string data type. But I'm trying to assign a datetime value to a string. That would not work. I need to convert this to a string first. So what I need to do is apply toString to it, right? That toString. And technically, there's an option for long date, so on and so forth. But we're going to use the convention that we just learned. So if I need to show a date that looks like this, that looks like long date. So uppercase D in the toString, right? So let's run that. See if I actually get the current date to show on the screen. Okay, so that's showing the current date, and I'm happy with that. Perhaps the next thing I want to do is show the current time. So I would maybe go ahead and do LBL time dot txt, and I'm going to reuse the variable. Now you get the idea of why it makes sense to create variables, because I can reuse it in my code. I have a container that's holding the same value. The date and time was already computed on the first line. There's no reason why I need to recompute that each time. I can keep it in this bucket called today's age and use it in multiple places in my code. So let's go ahead and do lowercase t and give that a shot. So if we run that, hopefully we see what we're looking for. And I see the time, I see the date, I'm happy. we're good to go, right? So that concludes what I need to do in the page load event. Now, the rest of these values are displayed when you click on the Calculate Total Charges button. So I'm going to need to return back to my user interface and create an event handler for this button. And to do that, you simply want to double-click the button. Please remember not to double-click these text boxes. Sometimes students forget, they double-click the text box and then they get all kinds of errors. If you double-click anything in this interface, you're creating an event handler. So if your intent is not to create an event handler, do not double-click. If you double-click and you're comfortable with HTML, you go back and fix the code. Otherwise, simply delete this control and re-add it and make sure you don't double-click on it. Right? You can click on it once, but double click in this interface means you want to create an event handler. But since that's what I want to do for this button, I'm going to double click that, and notice I have a method or event handler created for the name of this button, which is btn calculate underscore click. That's the click event handler. So I want some code to run in this method when a user clicks. So a user is going to click once, but for me to create the event handler, I need to double click on it, right? Sometimes people get confused, but you get the connection now. So if you recall what we did in the previous lab, we created some steps. Step 1, create and initialize input variables, right? I can probably go ahead and close this guy out, because from this point on we're simply going to write code. We're not going to design the user interface. Step 2, in a calculator app, we want to create output variables. Step 3, we want to perform the calculation. Just adding some comments to guide you so you know where your code needs to go. Display the results on the screen. Something like that, right? Okay, so here we go. So I'm going to create a variable. It's a string type because I happen to know the value the user is going to be typing in numnites is in the .text property. .text property is always a string. I'm going to start this off by saying I'm going to create a variable called numnites. You can call it whatever makes sense to you. And I would assign it a value from txt numnites, but specifically the .text property, which is a string. Left-hand side must match right-hand side. That is true in this case, right? In terms of data types. And I'm going to create another one for nightly charges. That is going to be assigned a value that the user is going to type in into the txt nightly charges text box. And by the way, that is held in the .text property. Okay. The problem, though, is to use the value that was typed in, I need to convert this back to a numerical data type. So I am going to create another bucket, a double type. Let me call it dNumNights. Okay, just so you get the idea that this is different from this variable. This is a string variable. This is a double variable. Eventually, you'll be able to do this on one line. I just want to break up the problem into smaller chunks to make life easier for you, so you get where we're getting the value and where we're converting. So to convert a string, we need to use double.parse, right? The double.parse. And I will plug in numnights. Numnights is a string value, and I can convert that string to a double data type and hold it in this bucket. And this is the bucket that I'm going to use for my calculation. In the same vein, I'll do something close. This time dNightly charges, which would be double that parse, right? Remember, I'm doing double because I don't want to have rounded values. I want the calculation to be accurate. So I'm going to use double instead of integer, although I know number of nights is some type of integer value. I can't go wrong with double. Okay, plug that in here. And at least I have enough to get the first calculation. You need to do the same thing for the rest of these input values, right? But I'll leave that to you. That's part of the challenge that you're trying to complete. Step 2 now is to create the output variable. So now I'm going to create some double data type, because when I multiply number of nights by nightly charges, I expect some type of double to be output. So I'm going to call it total room. What did we call this here? Total room charges. And I can perhaps initialize it right away, or I can do something like this. So let's follow this convention. I get the green squiggly line is just a warning. I've declared a variable, I haven't used it yet. Shut up Visual Studio, I know what I'm doing, and I'm going to do that in step 3. Right? So in step 3, I'm not going to declare the variable again because the variable is already created in memory, so I can just use it. Now I'm going to assign a value of d num nights times the nightly charges, right? I'll plug that in, do the multiplication of whatever the user typed into these two text boxes, plug it into that. And now I want to display it on the screen. And to display it on the screen, that would be showing up in LBL total room charges. So I need to know the control that would show the output. So LBL total room charges use IntelliSense, right? So you know which specific label control you're trying to set the value to. And now this is going to be total charges. So let's give that a shot. And you see I get this red squiggly line. This is a text string. .text is a string data type. I'm trying to plug in a double. Cannot implicitly convert type double to string. I need to convert this to a string first. Okay, so I'm going to convert this to string by using the toString property. Now it looks like this is good. I'm going to run this and see the output. So if I were to type in, let's go with the test data that was in here. So 5 and 80.5, right? So 5, 80.5. I get 402.5, which is pretty close. I don't have the $ in front of it, and I only have one decimal place. So let's go fix that, right? We know we can do toString C to fix that. So I'm going to kill this guy. I'll close it out, if you will, and simply plug in the toString C, currency, and show me something good. And I'm going to, this time I'm going to cheat and just select my previously entered values. Chrome happens to remember that. Now I get 402.50. I'm on the right track. So I'm going to leave you to figure out this stuff and plug in, calculate the rest of these. It'll give you some nice repetition for this exercise. Keep in mind, when you start testing this, it might make sense to perhaps set the default value of room service to 0 and phone number to 0 and other to 0. Right? If you want to test a scenario where this is not, a user doesn't enter anything. Because if you try to convert a blank value, right, the user types in no value and try to convert it to double, you're going to get an error. Unless you want to go ahead and apply the try-catch logic that we covered previously, then you can handle that type of exception. This would be a good place to do exception handling. Then you'd be able to improve the code, right? For now, this is a very good exercise, gives you some good ideas of how to implement this calculator app recipe, do some data type conversions, show it in a control property notation, and build a very simple web application. And that's all we're going to cover here today. Have a great weekend and talk to you later. Bye-bye.